Good day. My name is Francois from Merwe. I work for IBM in South Africa, and I would like to show you how to code the Corwin-Schultz Estimator in IBM Event Automation. The Corwin-Schultz Estimator uses daily high and low prices to estimate the bid-ask spread of a stock. It assumes high prices reflect buys and low prices reflect sells, so the ratio captures both price volatility and the spread itself. By factoring out volatility based on previous days' highs and lows, the estimator isolates the spread with a simple calculation, making it efficient and popular for research and event studies. This slide explains the Corwin-Schultz estimator formula. I've broken it down into a few simple steps. The important one is that we need to calculate first the spread. The spread is taking the high price over a certain period and subtract the low price from it. How do we do that with event processing? I've used a set of data I could play repeatedly for the demonstration. The data was a pair consisting of a timestamp and the rand-dollar exchange rate. I played this data with the generation utility into IBM Event Streams, or Kafka. In the real world, this data will be published into IBM Event Streams from, for example, Bloomberg. Now, how does Event Automation process this data? The most critical first step is to calculate the spread over some time window. I've used a spread of 20 seconds for this presentation, but a value of 24 hours or a week might be more practical in the real world. So the spread was calculated from my stream of data that is going into events. And then Event Automation will throw a window that I can pick. In this case, I've picked 20 seconds. This time window X is 20 seconds and time window X plus 1 is 20 seconds long. Inside that time window, event processing will calculate the spread. It will take the biggest value minus the smallest value, and that will give the spread for that window. Now that I have the spread for every 20 seconds, I can use the rest of the formula to calculate the Corwin-Schultz estimation. This will give me a new result. So I get a new stream of results every 20 seconds. Now, how do I take this new stream and visualize it? I've had Kibana installed on my system, and I've used that to draw 3 graphs for me. The Corwin-Schultz top left, the spread distribution bottom left, and the actual spread data in the top right. The financial gurus will now use these graphs to interpret the market. In the second part of this video, I will briefly explain how I built this demo with IBM Event Automation. I'll explain the detailed build in a follow-up video. To simulate my input data, I've made use of App Connect Enterprise. I've actually only used the top part of this little flow. The first thing is my data that's coming in was CSV messages, and I'm actually just mapping it straight to a JSON type of data. Secondly, I'm building in artificial wait states to sort of simulate what is coming from the market. And then lastly, I'm just popping the message with my Kafka producer node into event streams. With my ACE flow running, I will want to copy my input data, the CSV file, into the container. So I'm just finding my ACE pod, copy that information, and then copy the file data, the CSV, from my machine straight into the pod. This will serve as the input data for my simulation. Next, I'm going to event processing, and let me show how event processing works on the inside. This is the flow I've created that's taking that raw data from the event streams, and then it manipulates that data and do the calculations until I receive an answer, the Corwin-Schultz estimation. In this first bit, I'm making use of throwing that window over those 20-second intervals to calculate minimum and maximum values. I'm not going to go deep into the detail, but one of the strong points of event processing is that you can edit these formulas with an assistant. It's an Excel-like way of picking formulas. On the screen you can see there's a huge amount of formulas, financials, string manipulations, comparisons, etc. that you can do with the tooling. It assists you in building any of these complex formulas that you would need for any of the calculations in the Corwin-Schultz estimation. By manipulating the data in these nodes, I'm slowly building up a new set of data for my original date stamp and rand dollar exchange rate. On the screen you can see I've got now a time stamp, that's the end of the 20-second period, as well as a high price and a low price. Of course, I need this high price and low price to calculate the spread. See, this node will calculate the spread. And you see the formula there is high price maximum minus low price minimum. Again, a quick look at the assistant. And now you can see there's a spread field that was added to my output data. The next node will calculate the alpha. You'll see it's the ln of 2 plus the spread divided by 2 minus the spread. In the next few nodes, I'm tackling this last bit of the Corwin-Schultz estimator. So you'll see this bit will do e to the power of alpha. And now you can see we have e to the power of alpha added to our data. The next few nodes will be more of the same, so I'm skipping those. But I'm running the simulation now. Straight from my tooling, I'm actually running the simulation. And you will see it will go and read through that event stream, and then it will start to produce output events for me. As this flow calculates every window of 20 seconds, you can see the Corwin-Schultz estimator values is printed out to the screen. Let's stop the flow. This output only shows me the Corwin-Schultz value, but I also would like to see some of those other values so that I can display those Grafana graphs on the screen. So I'm deleting 2 of those, rerun the information, and from the Corwin-Schultz Estimator 2 you can see there's a lot more fields on the screen. There's the timestamps, there's high prices, low prices, the spreads, etc. In practice, you would write all of that information to new event streams, and then you would allow the Grafana tool to pick up that information from event streams and display it as nice graphs on the screen. As you can see, this tooling is very versatile. You can chop and change, add new information, and really manipulate the data until it shows on the screen what you need to see. It also makes it very easy for business analysts to use this tool. Everything in here is drag and drop, pick from a list kind of information. It makes for a play area. Use the data, change the data, combine the data until the business analysts see the information that they can use. Of course, then they can pass it to the IT department to actually instantiate it in a runtime environment. Thank you for watching this presentation. For more information and how to contact me, please see the closing slide. Have a nice day.